Hey guys, my name is Ryan Schumacher. Just a little bit about myself. I'm in my fourth year of teaching at Palmyra Era Middle School. I taught 1 year in the Reading School District in 6th grade, and I've been teaching here for 3 years now. In 8th grade, I teach algebra and pre-algebra. So my chapter that I covered was chapter 26, which was on graphing and graphical methods. And the main intention of this chapter is pretty much a mathematical basis, and the methods are intended to allow for visualization to take place. So most of us are going to be familiar with graphing, what it is, since we've used it when we taught how to graph. But some of the graphical methods might be fairly new to us. They're very engineering based, but some of them are on a basic level that we could probably cover. So, like I said, the ultimate goal, though, of this chapter is really just to focus on the visuals that a graph and these methods allow us to use to support problem solving. So, what is graphing? All right, so it's typically described in math as a collection of ordered pairs that is set on a two-dimensional plane. Sometimes it's on a three-dimensional plane. So if it's in 2D, you have two axes. You have the x-axis, that's known as your independent variable, which is the horizontal axis, and you have your y-axis, that is known as the dependent variable, which is your vertical axis. I'm pretty sure most of us are familiar with that for the most part. When you get into some of the more complex theories, you have 3D, which you have x and y as the independent variables, the horizontal plane, and you have the z-axis, that's known as your dependent variable, which is the vertical plane. So that's just a little overview of what graphing is. But how is graphing actually used? And I've mentioned this already. It's the visual piece, all right, for engineers when solving their equations. So it allows us to recognize how different plotting formats can and should be used to provide the most beneficial way to display the different types of data. So the first thing that they talk about is in table 26-1 of the different forms. So you have a scatter plot that shows points of a relationship in two sets of data. So it kind of shows the presence or the absence of a pattern. You have a line plot that is a graph that displays data as points or maybe check marks that shows the frequency of each value, and it shows the trend. You have a bar chart that uses comparison between different categories, and you have a pie chart, which is, we know it's a circle, and it's divided into different sectors that represent a portion of the entire whole, so how each factor is contributing. So we're pretty familiar with those. Those are some very basic graphical methods that can be used in a classroom. When it comes to engineers, they will use these at, like I said, a more basic level. Theirs will be a little bit more in depth, so I provided a couple of basic ideas here of those four from that table. But when we get into the idea of more complex graphical methods, engineers might not be able just to use the pure mathematical approach of using computation. So they use these graphical methods to use them as a visual representation. So a lot of them involve 2D representations, but they're typically used in a 3D situation. So the next few slides get a little bit more intense with what the different methods are. We're not expected to necessarily understand them fully, but you can kind of see how they're used in different parts of engineering fields. So the first one is a free body diagram, all right, and that essentially is used by physicists and engineers that they are looking at how forces are acting on a certain object, all right. So it is very helpful in problem solving. Even if you're doing actual calculations, they can actually use these visuals to support their reasoning. So you can see the photo in the bottom right that shows the forces of gravity on the bike and on the individual. You have the different applied forces pulling it in different directions here. The one that we're probably most familiar with is a Venn diagram. It shows the relationship among sets and subsets of information. It helps with grouping and organizing. We use this in all different types of content areas. So specifically in this chapter, in figure 26-3, they show the relationship among different types of metals, ceramics, and polymers that just show how they kind of work together. All right, so we've used this numerous times probably in ELA. You use it a lot in math to categorize things. So it's one of the more basic representations that we will see. You have something called Moore's circle, which is a graphical representation that shows the state of stress at a point in a material or structure. It's used a lot in mechanical engineering. It's used in something called geotechnical engineering for the strength of different soils. And it's also used for structural engineering for the strength of built structures. So it looks quite complex. It makes a little bit more sense to the engineer, but it's a visual representation that allows them to break it down into simpler parts. You have something called Ewald sphere. It's a geometric construction that is used in the diffraction of electrons, neutrons, and X-ray crystallography, which deals with crystalline materials. So it's very helpful for them to break it down. They can kind of see what works well and what does not work well. It's a little bit complex at our level to kind of comprehend right now, though. And then the last one that they talk about is something called a load deflection diagram. This essentially is talking about the idea of springs and spring systems and how they kind of interact with each other. It talks about the graphical depiction of the angle that the spring might be applied to. So they use it in a bunch of different areas. The one that Messler talks a little bit about, and I did a little bit of research, was about beams. So if you think about building infrastructure, they have to determine, are beams going to be straight? Are they going to be curved? So the idea of these diagrams help them understand what is going to work best when constructing these different types of buildings. So with that being said, some basic classroom connection, without going into too much detail, at least in math class, we do Venn diagrams with two-way frequency tables. So with the Venn diagram being constructed there, you can kind of see it outlined in blue and yellow. It's a way to show the frequencies of different variables. What do people like in one situation, what do people like in another situation, and what are the similarities. So that's just a basic lesson that we teach in 8th grade. The second one is scatter plots, and I know I've talked about that a little bit earlier, but we use scatter plots as a whole unit. It's comparing any type of data, but it allows the students, at least in our classes, to kind of gain a perspective of a hands-on approach to this content. So we do a couple of extensions with scatter plots known as Bungee Barbie and Spaghetti Bridge. So if I pull that up for you for 1 second here. Bungee Barbie essentially is allowing students to see how many rubber bands the Barbie doll can kind of be attached to safely jump from a certain height. So the more rubber bands you add to it, the more the possibility is it goes further and further in terms of the distance. So they are constructing, this process through this idea, and they eventually come to the idea of making a scatter plot as a visual representation to see how the number of rubber bands is associated with the distance in this case. And the other one, which seems to have an error at this very second, is Spaghetti Bridge. We'll see if it comes up here. There it is. Again, this is an idea where students get the ability to construct their own bridges. They, specifically in our class, when we design this, the students are given pieces of angel hair pasta. They take 2 desks and they face each other, and they have a red cup with a string attached to it where they dangle the cup over the spaghetti and they place pennies into the cup and they count the pennies to see how much each strand of spaghetti can hold. So you start out with one strand, then you move to two strands, then you move to three strands as each time the spaghetti breaks. And when we reach a certain point, they gain a perspective as to how much weight the spaghetti can hold. But not only that, then they see that in a realistic way where the bridge represents an actual bridge structure that allows them to see how engineers are building actual bridges with weight. So it's something, interactive, but it's again that more visual representation that allows them to see how solving the problems, in terms of equations, makes it a little bit more simplistic. So overall, I think it's a very straightforward chapter. Like I said, there are some more complex graphical methods that we might not use to our extent in classroom, but we definitely use the idea of Venn diagrams and scatter plots and line plots and pie charts to assist our students in terms of their learning. So I really enjoyed it. I think it was a good representation of what we use in our classes, and I would be interested to see how other examples come from this chapter. Thanks.